So we are on Energy Test A. This is page 3. So we are moving on to starting at question 10. Okay, so on question 10, what we're trying to get to is if the mechanical energy is conserved on this roller coaster, we're pretending that there's no friction, and so no thermal energy would get created, then that means that all of our energy, our total amount of energy, has to be the same the whole time on the roller coaster, which means you can say if we calculated our total energy down here in number 8 to be this amount, then the same answer would be our answer here. So you would just need to tell me that the total energy at position 4 is going to be the same as the total or as the gravitational potential energy at position 1. There's no kinetic energy at position 1 because we're not moving, so all of that energy would have to be potential. So if we just even look at, here's position 4 compared with position 1, all of the energy at position 1 would have to equal all of the energy here, which is going to be some potential energy plus some kinetic energy. And that's what my energy at position 1 is going to be. But all of that energy, this kinetic energy, would have to be potential energy up here. Okay, so only potential energy up here, and it's going to actually be made up of whatever potential energy there is here, and also the kinetic energy that is here. Okay, so good response that I got on number 10. No energy would be lost at position 4. So position 1 is all equal to PE, so the total energy from 4 is equal to the PE at 1. Energy is neither created nor destroyed, so it will always equal the total energy. So that's what's going on in that first question. In the second one, this is the bonus. Number 11 is the bonus. And so you may have tried it, and if you tried it, then I at least gave you 1 bonus point on there. If you actually solved it, then you got 5 bonus points, which we can see right here. So this student actually took the formula and then was trying to solve for the height here. It got a lot of information in there. It just needed to actually divide these numbers over, which this student had taken the formula and actually rearranged it. So they divided by mass and they divided by gravity. So they took this answer and then divided by the mass and then divided by acceleration due to gravity, g, and got the about 44 meters high, and that's actually the correct answer here. So got full extra credit points on there. Then I've got down here some answers for our matching. So in that first column, thermal energy, solar energy, and nuclear energy, all 3 of those are non-mechanical. Kinetic energy is mechanical. It's something that you can see. It's motion, and we know that mechanical energy includes kinetic energy, the energy of motion, and potential energy, the energy of position. Second column, gravitational potential energy, chemical energy, elastic, and electrical. Chemical and electrical, those are non-mechanical. We can't actually see chemical energy, and we can't actually see electrical energy. Gravitational potential energy, that's how high an object is. We can see that. Elastic potential energy, that's stretchy. We can see if something is stretched or compressed. Those are our mechanicals. Chemical and electrical are non-mechanical. Last portion is the matching section. This, if you wrote the letter next to that, that made it so much faster for me to grade. Thank you. Windmill blades rotating, that is motion, so that's kinetic energy. A box lifted above the ground, that's changing its position to a higher position, gravitational potential energy. A cell phone charging, that's electricity, electrical energy. An archer pulling an arrow back, that is elastic potential energy, the stretching. The process that powers the sun is nuclear energy. And then what you have after eating a sandwich is chemical energy.